Hello everyone, I am back with other set of questions related to mathematical physics in CSIR UGC NET syllabus of vector algebra topic. So the following questions we'll be seeing it today. The questions are: the first question, an unit normal vector to the surface z is equal to x square plus y square at the point 1, point 2.5 is. So we have to find here the unit normal vector. So first, the function which is given by the question is f is equal to z is equal to x square plus y square. So we can write it as function f is equal to x square plus y square minus z is equal to 0. This is the surface function. So we have to find the unit normal to this surface function. For finding the unit normal, the formula for finding the unit normal vector is del f at the given point x, y, z divided by mod del f on x, y, z. Let me change that x here. X, y and z mod. So first we have to find del. So del f is nothing but gradient of f. Gradient of function f. So how we will be finding that is del f is equal to, in place of del, we have to substitute I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. Then f. What is f? F is x square plus y square, x square plus y square minus z. So we have to differentiate this function with respect to x for the first term, with respect to y for the second term, and with respect to z for the third term. It can be further expanded like this. That is equal to I dou by dou x, x square plus y square minus z plus j dou by dou y, x square plus y square minus z plus k dou by dou z, x square plus y square minus z. So it can be simplified as del f is equal to I cap dou by dou x, x square plus y square minus z plus j cap dou by dou y, x square plus y square minus z plus k cap dou by dou z, x square plus y square minus z. So I have rewritten that same equation for easy simplification. So it will become here 2x I cap. In this case it will be plus 2y j cap. In the last case it will be minus k cap. So that is del f. Now in the question they have given some points del f at the point 1, 2, 5. So substitute 1, 2 and 5 in place of x, y and z. What we will get is 2 into 1, 2 I cap. 2 into 2, that is 4 j cap. And here there is no z parameter, so simply minus k cap. Now we have for unit normal vector, unit normal del f at 1 to 5. So 2 I cap plus 4 j cap minus k cap, and mod of this one. So mod of this one will be root of sum of the square of coefficients of I cap, j cap and k cap. So 2 square is 4, 4 square is 16 and minus 1 square is 1. We will be putting plus or minus sign before it as it is a unit normal vector. So on further simplification we will obtain plus or minus 2 I cap plus 4 j cap minus k cap by root of 16 plus 4 is 20 plus 1 21. This is the unit normal. The answer for the question is found. The next question is, if f vector is given as x I cap plus y j cap plus z k cap, then what is its divergence? So divergence formula is del dot f vector. We have to differentiate between divergence and gradient. In gradient, this dot is not present. So in that case, we will be differentiating this whole function with respect to x, then with respect to y, and then with respect to z separately each time for each term. While in this case, the mechanism will be different. Again, we will write del function as I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z dot. Now write the function of f, that is x I cap plus y j cap plus z k cap. So as the operator dot is present here, so the product will be the coefficients of similar unit vectors, that is I cap with I cap. So these two will get multiplied, then j cap with j cap will get multiplied, then k cap with k cap. Those multiplications will only occur. The remaining terms, even if we do multiplication, the further simplification will get the answer as 0. So we ignore that. So here I cap into I cap. So that is dou by dou x into x. Second term, the coefficients of j cap of del with j cap of f. So that is dou by dou y, y. Similarly, the third term we will get dou by dou z into z. So differentiation of the first term we are getting as 1, second term again 1, third term again we are getting 1. So the sum is 3. So the answer for this question is del dot f vector is equal to 3. This is a simple divergence formula. Similarly, again one more question we have obtained, like if the function phi is equal to yz, then what is its gradient? So its gradient is del phi. Again write the equation for del, that is I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z, and then the value of function. So this term will be multiplied with each of the terms in del, and we will differentiate afterwards, like I cap rho by rho x into yz plus j cap rho by rho y into yz plus k cap rho by rho z into yz. So in the first term we will get the answer as 0, as there is no x term in this one to differentiate. Second term, there is a y term is there, so it will differentiate as z j cap. Third term, z term is there, so it will differentiate as y k cap. So the answer for del phi is z j cap plus y k cap. That's the answer. Now we will move on to the fourth question, that is the electric field due to a point charge q is expressed as E vector is equal to q r cap by 4 pi epsilon naught r square. Then what is the divergence of the electric field due to a point charge? So we have to determine del dot E cap. So as there is a position vector, what we will be doing is, in place of E, we will first del dot del vector dot E cap vector q r cap by 4 pi epsilon naught r square. This r cap can be written as, we can write r cap as r vector by r. So substitute here, you get del vector dot E vector is equal to del vector dot q r vector by 4 pi epsilon naught r cube. So the here q by 4 pi epsilon naught are constant terms, so we can take that out. We can write like q by 4 pi epsilon naught del vector dot r vector by r cube. Now it is known that del vector dot r vector by r cube is 0. So what is we will get is as del dot vector we are getting as q by 4 pi epsilon naught del vector dot r by r cube. As this term is equal to 0, so we will get del dot E vector is equal to 0. That means divergence of electric field due to any point charge is 0. Is true. Next, we are going forward with other question like the constant. We have to determine the constant a, so that the function x plus 2y into I cap plus 2y minus 2j cap plus 2x plus az t cap is solenoidal. So whenever a function is solenoidal, that means the divergence of that function del dot f is equal to 0. So here f is given as x plus 2y I cap plus 2y minus 2j cap plus 2x plus az k cap. So we have to find del dot f and equate it with 0. The vector dot f vector. If we do it, what we'll obtain is rho by rho x 1 because in this term there is no x term. Here we get 2, and from this term we get plus a. So del dot a should be equal to 0 for being a solenoidal field. So that means 3 plus a is equal to 0. So the value a should be minus 3. Next question. If R is a position vector, then the curl R is given as curl. We have curl is del cross R vector, that is curl. So as R is a position vector, that means R is equal to x I cap plus y j cap plus z k cap. That is the position vector formula in 3 coordinates. So del cross R can be found as determinant of the first row we have to write I cap, j cap, k cap. Second row we have to write the coefficients of I cap, j cap and k cap in del. That is dou by dou x, dou by dou y, dou by dou z. The third row the same coefficients of I cap, j cap and k cap in R vector. That is x, y and z. Now if we find the determinant of it, what will obtain? I cap into, we will note the first column and the first row, dou z by dou y, that is 0, minus dou y, dou by dou z into y, that is again a 0. Second term minus j cap, ignore the first row and the second column, dou by dou x into z, again a 0, minus dou by dou z into x, again a 0 because x can't be differentiated with respect to z. Again for the third term k, ignore the first row and the last column, dou y by dou x, again 0, x into dou by dou y, again 0. So we will get del cross R vector is equal to 0 as the answer. Now time for homework questions. So homework question for today's slot is, we have to determine the value of a, b and c such that the function f of this term is irrotational. The hint is, you have to use the formula del cross f vector, and as it is an irrotational vector, that means del cross f vector should be equal to 0. So find the curl of del cross f and equate it with 0 to determine a, b and c. Another thing which you should notice, I vector, j cap and k cap, I cap, j cap and k cap are independent vectors, independent to each other. That also you should keep it in your mind to solve this question. The next question for homework is, if a vector is equal to I cap x and b vector is equal to j cap y, if a vector is equal to I cap x and b vector is equal to j cap y, then we have to find del a dot b. So first we should determine for this A dot B. First find this one. Then gradient of A dot B. You have to find gradient of A dot B, not divergence. You have to find gradient of A dot B. Remember this one. So let's see tomorrow then. Thank you. And if there is any doubt in the questions, kindly post it in the comment section. If you like the video,